It's the only rock we eat. Ancient civilizations used it as currency. Wars were fought over it. But today, we're told to fear it. What's the real story with salt? I'm Eric Johnston, and I'm not a chemist or a nutritionist. I'm just someone trying to understand how this crystalline mineral keeps us alive. On this episode of Food Truth, we're exploring the substance that's both essential for life and potentially dangerous in excess. We'll discover how your body maintains its delicate salt balance, why different salts cost wildly different prices, and whether that pink Himalayan crystal is really worth the premium. Join me as we trace a single salt crystal's journey through your body and uncover the science behind humanity's oldest seasoning. This is Food Truth, Episode 4, The Salt Show. Before we follow a salt crystal through your body, let's explore where salt came from. Like all elements, the sodium and chlorine that make up table salt were forged in stellar crucibles. Sodium emerged from dying stars in their final phases, while chlorine formed in the violent deaths of massive stars. These elements scattered across space, eventually becoming part of our forming Earth. But why did these particular elements become so crucial for life? The answer lies in their atomic structure. Sodium readily gives up its outer electron, becoming a positively charged ion, while chlorine eagerly accepts an electron to become negatively charged. This dance of electrons creates one of the most stable ionic bonds in nature. The result, sodium chloride, would become essential for life itself. Your blood contains almost exactly the same concentration of salt as Earth's ancient seas, about 0.9%. This isn't coincidence. Life evolved in ancient oceans, and our cells still require the same ionic environment that supported our earliest ancestors. Every cell in your body maintains this ancient balance. The precision of salt regulation in your body is fairly remarkable. Special sensors in your brain, called osmoreceptors, can detect changes as small as 1 to 2% in your blood's salt concentration. These sensors trigger complex hormonal responses that maintain perfect balance. It's like having a molecular thermostat system that never sleeps. Salt's role in your nervous system reveals its fundamental importance. Your neurons maintain different salt concentrations inside and outside their membranes, creating an electrical gradient. When neurons fire, sodium ions rush in through specialized channels, creating the electrical pulse that carries information. Your thoughts literally ride on the waves of sodium. Even your muscles depend on precise salt balance. Calcium ions, working alongside sodium and chloride, enable muscle contraction. Changes in salt concentration can affect muscle strength and coordination. This explains why athletes pay careful attention to electrolyte balance during competition. Your digestive system uses salt in surprising ways. Stomach acid consists largely of hydrochloric acid, created using chloride from salt. This acid not only helps digest food, but also protects you from harmful bacteria. Meanwhile, sodium helps you absorb nutrients across your intestinal wall. Your kidneys act as the master regulators of salt balance. They filter your entire blood volume around 400 times a day, controlling how much sodium and chloride to keep or excrete. This filtration system is so sophisticated that it can adapt to varying salt intake within mere hours. Inside your cells, salt plays crucial roles beyond water balance. Sodium-potassium pumps in cell membranes maintain essential concentration gradients. These pumps use about 25% of your body's energy at rest, and that's how important salt balance is for your cellular function. But your cells don't work with sodium chloride directly. Once salt enters your body, the sodium and chloride ions separate, each playing distinct roles. Sodium influences blood pressure and fluid balance, while chloride contributes to stomach acid and helps neutralize excess bases in your blood. The movement of salt through your body involves multiple hormone systems. Aldosterone influences kidney salt handling, while vasopressin affects water retention in response to salt levels. These and other hormones work together like a molecular orchestra, maintaining perfect salt balance. Understanding salt's journey through your body reveals why it's both essential and potentially dangerous in excess. Your body carefully maintains salt levels within a narrow range because these concentrations affect every aspect of cellular function. This delicate balance reflects millions of years of evolution, fine tuned to keep you alive. Okay, now we're going to follow a single salt crystal's journey through your body. At T minus 2 seconds, a crystal of salt lands on your tongue. Immediately, your taste buds detect its presence. Saliva production increases as your brain prepares for this essential mineral. At T minus 0, the crystal begins dissolving. In mere milliseconds, sodium chloride separates into sodium and chloride ions. Your taste receptors send urgent messages to your brain, mineral incoming. At T plus 5 seconds, dissolved salt enters your stomach. The chloride ions immediately contribute to stomach acid production, while sodium ions begin their journey through your digestive system. After 2 minutes, your small intestine receives that salt solution. Specialized channels in the intestinal wall begin actively transporting sodium ions into your bloodstream. Where sodium goes, water follows. After 5 minutes, sodium ions enter your blood vessels. Your body immediately detects the slight change in salt concentration. Osmoreceptors in your brain signal your kidneys to adjust their filtration rates. At T plus 10 minutes, the salt has fully entered your circulation. Your blood vessels slightly expand to accommodate the additional fluid volume that followed the sodium. Blood pressure sensors detect these changes and trigger adjustments. After 30 minutes, your body's homeostatic mechanisms are in full swing. Kidneys adjust their sodium excretion, blood vessels fine-tune their diameter, and hormones regulate water retention. After about an hour, perfect balance is restored. The sodium ions have been distributed exactly where needed. Some are now powering your nerve transmissions, while others help your muscles contract, while others maintain cell membrane potentials, and the excess is then prepared for excretion. After 4 hours, your kidneys have filtered and reabsorbed these sodium ions multiple times, keeping exactly what your body needs. Any excess sodium is eliminated, maintaining your precise salt balance. About 24 hours later, the journey is completed. Some of the original sodium ions have been used for crucial body functions, some stored for later use, and some eliminated. Your body maintains its perfect salt concentration, ready to process the crystal that arrives. From ancient seas to modern cells, salt remains essential for life. Understanding its journey through your body reveals why the simple crystal is both vital and potentially dangerous. The next time you reach for the salt shaker, remember, you're not just seasoning your food, you're participating in an ancient chemical dance that keeps your body going. Salt shaped human civilization more profoundly than perhaps any other substance. Ancient trade routes called salt roads connected distant cultures. Cities grew around salt sources. The word salary comes from the Roman practice of paying soldiers in salt. Religious texts worldwide mention salt's importance. It features in purification rituals, ceremonial offerings, and symbolic practices. Jewish, Christian, Islamic, and Hindu traditions all recognize salt's sacred significance. African and Asian cultures developed sophisticated salt-making techniques thousands of years ago. The Chinese drilled deep wells for brine extraction. West Africans mastered solar evaporation methods. These technologies influenced local cuisines and preservation methods. Native American peoples established trade networks around salt sources. The ancestral Puebloans built roads to salt deposits. Great Lakes tribes traveled hundreds of miles to collect salt. These salt-gathering expeditions became important cultural events. Salt taxation sparked numerous revolts throughout history. The French Revolution was partly fueled by the gabelle, a hated salt tax. Gandhi's Salt March protested British salt monopoly in India, and these events show salt's economic and political power. Modern cultures maintain complex relationships with salt. Japanese sea salt remains crucial in traditional cuisine. Mediterranean cultures prize different salts for specific uses. Understanding these cultural practices reveals salt's enduring importance. Beyond its role in food, salt proves crucial in modern industry. Chemical manufacturers use it as a basic raw material. Water treatment facilities depend on it for purification. The chlorine in salt helps produce everything from paper to pharmaceuticals. Salt plays a vital role in winter road safety. Road salt lowers water's freezing point through a process called freezing point depression. Though effective, this use raises environmental concerns about soil and water contamination. The electronics industry relies on ultra pure salt compounds. Silicone chip manufacturing requires extremely pure sodium compounds. Battery technology often involves specialized salt solutions as electrolytes. These applications demand increasingly pure forms of salt. Modern oil drilling depends on salt solutions called drilling muds. These specialized brines help cool drill bits and maintain proper pressure in wells. Understanding salt's behavior under extreme conditions proves crucial for energy extraction. Soap and detergent manufacturing begins with salt. The basic chemical reactions that produce cleaning products require sodium compounds that are derived from salt. This connection explains why early soap makers often worked very near salt sources. Scientific research continues finding new uses for salt compounds. From superconductor development to nuclear waste processing, salt's chemical properties make it invaluable in advancing technology. Salt plays a fundamental role in Earth's geological processes. Ancient seas evaporated to form massive underground salt deposits. These deposits influence everything from mountain formation to oil trap creation. Understanding salt geology helps explain Earth's structure. Ocean salinity drives global water circulation. Differences in salt concentration create density gradients that power deep ocean currents. These currents distribute heat globally, significantly influencing climate patterns. Salt deposits record Earth's history. Layers in salt mines reveal ancient climate patterns. Crystal structures preserve evidence of environmental conditions millions of years ago. Geologists read these records like pages in Earth's diary. Underground salt deposits create unique geological features. Salt domes form when buried salt pushes upward through denser rock layers. These structures often trap oil and gas deposits, making them economically valuable. Salt's interaction with groundwater shapes landscapes. Underground salt dissolution can create sinkholes and caves. Surface salt deposits create unique environments like salt flats and salt pans, each supporting specialized ecosystems. Modern climate change affects global salt distribution. Rising sea levels alter coastal salinity patterns. Changes in precipitation affect salt accumulation and erosion. These shifts impact both geology and biology. Life likely began in ancient seas with specific salt concentrations. Modern cells maintain internal salt levels remarkably similar to ancient oceans. This connection provides evidence for life's marine origins and shows how fundamental salt is to biological processes. Early life forms had to develop mechanisms for managing salt balance. The ability to maintain stable internal salt concentrations despite changing external environments marked a crucial evolutionary development. These mechanisms became increasingly sophisticated as life colonized land. Different species evolved varying salt management strategies. Marine animals developed ways to expel excess salt, while land animals evolved systems to conserve it. Desert animals show particularly remarkable adaptations for salt conservation. The human salt appetite evolved in salt-scarce environments. Our ancestors competed for limited salt sources, leading to evolved cravings and efficient salt conservation mechanisms. These adaptations influence modern eating habits and health issues. Salt's role in food preservation influenced human evolution. The ability to preserve food with salt allowed humans to store food longer and travel farther. This technological advancement significantly impacted human migration and population growth. Modern changes in salt availability create evolutionary pressures. High salt availability in processed foods challenges our evolved salt management systems. Understanding this evolutionary context helps explain current public health challenges. Salt balance is crucial in medical treatment. Intravenous saline solutions save countless lives by quickly restoring fluid and electrolyte balance. Understanding salt's role in health revolutionized emergency medicine and surgery. Medical conditions often disrupt salt balance. Kidney disease, heart failure, and hormonal disorders can all affect sodium levels. Monitoring salt levels helps diagnose and treat numerous conditions. Sports medicine relies heavily on understanding salt balance. Athletes in different environments need different salt replacement strategies. Medical teams use this knowledge to prevent heat illness and optimize performance. Modern medical imaging often uses radioactive salt compounds as tracers. These compounds help visualize blood flow and organ function. Salt based contrast agents make detailed medical scans possible. Wound healing involves careful salt balance. Proper sodium levels help reduce infection risk and promote tissue repair. This understanding influences everything from bandage design to surgical procedures. Salt's medical applications continue expanding. New treatments use specialized salt solutions for targeted drug delivery. Research explores salt's role in treating various conditions as time goes on. Salt's role in cooking goes far beyond flavor enhancement. It affects food texture by drawing out moisture and altering protein structures. Understanding these chemical effects explains why adding salt at different cooking stages produces different results. Salt preservation methods shaped culinary traditions worldwide. Curing, pickling, and fermentation all rely on salt's ability to control microbial growth. These techniques developed independently across cultures but follow similar scientific principles. Different salt types affect cooking differently. Crystal size influences dissolution rate and flavor distribution. Trace minerals in unrefined salts can affect both taste and chemical reactions. Therefore, professional chefs will choose specific salts for different applications. Baking chemistry depends heavily on salt. It strengthens gluten structures in bread, controls yeast growth rates, and affects browning reactions. Even sweet baked goods need precise salt amounts to achieve proper flavor and texture. Salt interacts with other ingredients in complex ways. It can reduce bitterness, enhance sweetness, and make aromatic compounds more volatile. These interactions explain why recipes often fail when salt is simply omitted. Modern cooking continues discovering new applications for salt. Techniques like salt crusting and salt aging expand traditional uses. Understanding salt's chemical properties drives culinary innovation. Rising sea levels affect coastal salt concentrations, impacting marine ecosystems. Changes in ocean salinity influence global water circulation patterns that regulate climate. These shifts create feedback loops affecting weather systems worldwide. Salt deposits provide crucial climate records. Layer analysis reveals historical climate patterns and helps predict future changes. Salt crystal formation under different conditions offers insights into past environments. Climate change affects salt distribution in soil. Changing rainfall patterns alter soil salinity, affecting agriculture. Desert expansion increases surface salt accumulation in some regions. Ocean acidification interacts with salt chemistry. Changing pH levels affect how marine organisms process salt. These changes ripple through marine food webs. Melting ice caps dilute ocean salt concentration near the poles. These changes affect marine currents and local ecosystems. Understanding these processes helps predict climate change impacts. Salt cycle changes influence cloud formation and rainfall patterns. Atmospheric salt particles affect precipitation. These mechanisms link salt distribution to global weather patterns. Your nervous system depends on precise salt concentrations. Sodium and chloride ions enable nerve signals through controlled ion movements across cell membranes. Without this electrical system, thoughts and movements would be impossible. Blood pressure regulation relies heavily on salt balance. Your kidneys monitor and adjust sodium levels constantly. This precise control system evolved over millions of years to maintain optimal cardiovascular function. Every cell in your body maintains specific salt gradients across its membrane. This concentration difference powers numerous cellular processes from nutrient absorption to waste removal. Cells spend significant energy maintaining these salt gradients. Muscle function requires proper salt balance. Sodium and chloride ions participate in muscle contraction and relaxation. Even slight disruptions in salt balance can affect muscle performance and coordination. Digestive processes depend on salt based compounds. Stomach acid contains chloride from salt. Bile salts, crucial for fat digestion, are produced using components from, you guessed it, salt. The brain carefully monitors body salt levels through specialized sensors. These osmoreceptors trigger thirst and influence behavior to maintain proper salt balance. This system shows how fundamental salt is to survival. The belief that everyone needs to drastically reduce salt intake oversimplifies the science. While some people are salt sensitive, others show little blood pressure response to salt intake. Individual differences in salt processing affects health impacts. Claims about specialty salts having significant health benefits often lack scientific support. While unrefined salts contain trace minerals, amounts are typically too small for meaningful health effects. The sodium chloride molecule remains the same regardless of source. The idea that salt causes water retention in everyone equally also isn't accurate. Individual factors like hormones, kidney function, and overall diet affect how bodies process salt. Understanding these differences helps explain varying responses to salt intake. Many believe ancient salt preservation methods are safer than modern ones. However, traditional methods often used more salt than necessary. Modern techniques typically achieve better safety with less salt through understanding microbial control. The misconception that all salt in food comes from the shaker ignores hidden sources. Processed foods often contain more salt than obvious salty foods. Understanding these hidden sources helps make informed dietary choices. Claims about toxic table salt versus healthy sea salt misunderstand salt chemistry. Pure sodium chloride is the same molecule regardless of where it comes from. Impurities, not benefits, often cause color differences in the natural salts. Scientific research continues revealing new applications for salt. From energy storage to water purification, salt's chemical properties drive technological innovation. Understanding salt behavior at molecular levels opens new possibilities. Climate change will affect global salt distribution patterns. Rising seas and changing weather will influence salt deposits and water salinity. Preparing for these changes requires understanding salt's role in Earth systems. Medical applications for salt compounds continue expanding. New drug delivery systems use salt-based carriers. Salt's role in cellular processes suggests potential therapeutic applications. Food technology explores salt alternatives and enhanced salt compounds. Efforts to reduce sodium while maintaining flavor drives innovation. Understanding salt's multiple roles in food helps develop better alternatives. Population growth increases pressure on salt resources. While salt remains abundant, accessing pure deposits becomes more challenging. Future salt production may require new extraction methods. Space exploration considers salt's roles in supporting life beyond Earth. Mars missions must account for salt needs in life support systems. Understanding salt's biological role helps plan long-term space habitation. The pink Himalayan salt industry promotes claims about superior health benefits, but science tells a more nuanced story. This salt, mined from Pakistan's Quetta salt mine, gets its color from trace amounts of iron oxide. While marketed as containing 84 minerals, most exist in such tiny quantities they have negligible health impact. Marketing often presents this salt as pure and untouched by modern pollution, suggesting it's superior to other salts. However, chemically, The sodium chloride molecule remains identical to that in other salts. The primary difference lies in trace minerals that constitute less than 2% of the salt's composition. Studies haven't demonstrated significant health advantages of pink Himalayan salt over other varieties. While it contains slightly more trace minerals than refined table salt, the amounts are too small to meaningfully impact nutrition. Your body gets these minerals more effectively from other food sources. The history of this salt simply adds to its mystique. The chlorine dates back to Alexander the Great's time, and the salt formed millions of years ago when ancient seas evaporated. While historically interesting, age doesn't necessarily correlate with health benefits. The price premium for pink Himalayan salt reflects successful marketing rather than superior nutritional value. While it may offer subtle taste differences and visual appeal, scientific evidence doesn't support claims of unique health benefits. Understanding this helps consumers make informed decisions about salt purchases. The environmental impact of mining and transporting this salt globally raises sustainability questions. Local alternatives often provide similar mineral content with smaller carbon footprints. This aspect rarely appears in marketing materials. In 1906, what seemed like a simple salt business in Michigan erupted into one of America's strangest criminal cases. The Morton Salt Company, already a powerful force in American salt production, faced an extraordinary threat from within the Morton family itself. Joy Morton's brother Mark had started a rival salt company, but with a dark twist. He began hiring saboteurs to contaminate his brother's salt supplies with ground glass and iron filings. His goal wasn't just business competition, it was revenge for perceived family slights. The contamination scheme went undetected for months until suspicious workers noticed unusual sparkles in salt batches. Investigation revealed an elaborate network of paid infiltrators in multiple Morton facilities. The scandal rocked the industry and threatened public trust in America's food safety. The case exposed the vulnerability of America's food supply and contributed to the passage of the Pure Food and Drug Act. Mark Morton's revenge plot inadvertently helped create modern food safety regulations. What makes this case particularly fascinating is how it combined family drama with industrial sabotage. The Morton brothers' feud wasn't just about business. It represented a deeper conflict about legacy, family honor, and the dark side of America's industrial revolution. The aftermath changed the salt industry forever. Companies implemented new safety measures, government oversight increased, and the Morton Salt Company's famous slogan, "When it rains, it pours," took on new meaning as they worked to restore public confidence. Well, that's it for this episode of Food Truth. You were with me as we took a deep dive into the only rock we eat, also known as salt. Join me next time as we take a look at carbohydrates, processed, unprocessed, the good, the bad, and the ugly on the next show. If you want more Food Truth, go to getfoodtruth.com. We'll see you next time.